Hello everyone, welcome back to the good stuff we've been doing. In the previous video we talked about the binomial theorem, but then we gave only a slight introduction and hints to what it says. Well, we learned how to expand x plus a, say a1, x plus a2, x plus a3, and then we'll continue us further to x plus a sub n. We say this is equals to, first of all, we have x to the n plus p1 x to the n minus 1 plus p2 x to the n minus 2. They will have plus pn x to the n. Here, this p1 here is this algebraic sum of these terms a1 to an, and p2 here is the algebraic sum, but we're taking two at a time, a1 a2 or a1 a3. Countless time we have explained why we do so. So if you feel like you are not getting it, please check through the previous videos. But then here again we are going to consider the case whereby a1 equals to a2 equals to a3, and they are all equal to an to each other. This product reduced to x plus, so they're all equals to a, so this reduced to x plus a all to the n power. That's what we have. Now what would this p1 be? P1 obviously would be when we have to add a repeatedly n times, so p1 would be a plus a plus a, but we're having n times, so it is na. What about p2? Well, p2, we're going to multiply a by itself, so it will be continuously. But how many times does it appear? Well, it equals number of times whereby if we have n things, 1 2 3 4, if we have n things listed out, let's see, and then we're going to take two at a time, we can list this guy together, list these guys together, or this one together. How many ways can we group n things taking two at a time? That is what this product will equal. For now we don't know what it equals, so we call it n choose 2. So this p2 will now be n choose a square multiplying n choose 2. That is what p2 will equal. Or if you prefer, you may write it as p2 will be equals to n choose 2 a squared. Now n choose 2 is number of times a squared would appear, and it is equal to the number of ways in which, given n things, how do we select 2? What about p3? Well, p3 would then be a multiplying by a itself. Oh, I've already explained this p1 p3 why we multiply itself. So if you're not following us, please, I encourage you to go to the playlist and check the previous video. So and a times a, so it will be a multiplying itself 3 times. But how many times does it appear? Well, we have n things and I'm going to take 3 at a time, so let's call it n choose 3, and then we'll be having a cubed because each of this is a cubed. This n choose 3, we are going to find a formula for it as we continue the videos in the channel. For now, that is how p4 will take the pattern. So here we'll be having that x plus a all to the n power will first of all be x to the n plus na, then plus then n choose 2. We will be having a square x to the n minus 2. That is the coefficient of x to the n minus 2. And yes, I forgot this part here. Here we are supposed to have x to the n minus 1. So here was no. Okay, I wiped up this part. So this is a n choose 3 a cubed. So sorry for the interruption. Here we have p1, but we're multiplying by x to the n minus 1. Then we have p2 multiplying by x to the n minus 2. And this we have defined p1 and p2 to be this. So what we'll be having is that x plus a all to the n will be now be, first of all, we have x to the n plus na x to the n minus 1, na x to the n minus 1, then plus, here we'll be having n choose 2 a square x to the n minus 2, then we'll be having n choose 3 a cubed x to the n minus 3. This will continue, whereby we'll be having n choose 4 a to the 4 x to the n minus 4. And the general term is that we have n choose n a to the n choose k and a to the k x to the n minus k. That is how the general term will continue. So this particular expression we've written out here is what we call the binomial theorem, because binomial we have x plus a two is if two term being expanded. So this is what it actually is. So the expansion of this is follows this pattern. Here we have the n choose 2 and n choose 3. So the first term we have to add all the terms, the coefficients here. The coefficient for the second term is we have to add all the terms, but we're taking 2 at a time. So how many are they is being counted by n choose 2. So this short binomial theorem we are seeing here, as we go further, we're going to work many theory concerning it. For now, we're only going to introduce it and move further with our discussion on algebra. Of course, this is A. So in the coming videos, we're going to work on still not binomial theorem, but how we are going to prove this binomial theorem using a method of they call it method of detached coefficients. We're going to see a way to prove this binomial theorem, where we have proved it using distribution, but we're going to see more method of proving it. For now, we're only concerned with proving it. These numbers n choose k, we'll calculate it in the same playlist, but later video in the series, not now. For now, we're going to work on method of detached coefficient to prove the binomial theorem in the next video. So thank you for watching. Please subscribe to the channel if you like my content. Have a nice day.